Hello, my name is Alexander. I'm delighted to demonstrate our jump tool, which we have implemented on top of Eclipse. The jump tool aims at bridging Java's annotation mechanism with UML's lightweight extension mechanism. It allows developers to automatically generate UML profiles from annotation-based Java libraries and apply these profiles to UML models, which are reverse engineered from Java applications. In this demonstration, I applied a jump tool to the JPA to generate the corresponding platform-specific UML profile, where the platform refers to the JPA. Then I reverse engineer UML class diagram from the Padstore reference application, which uses annotations, and show that these annotations are captured by stereotypes of the JPA profile. In the last step, I emphasize the practical value of platform-specific profiles by applying a slicing transformation that exploits stereotypes. Now let's switch to Eclipse and perform the three mentioned scenarios. To generate the JPA profile, I execute the jump tool on the source code of the JPA. For that reason, I create a new launch configuration and run it. Well, let's have a look at the generated result. As the jump tool generates standard compliant UML profiles, any UML modeling tool can be used to produce a diagram for them. I use Papyrus to visualize the generated entity stereotype. To use an example, it extends the UML metaclass type, which generally corresponds to type in Java. The added constraint restricts the stereotype application to exactly those elements that are targeted by the entity declaration of the JPA. Such constraint is at the modeling level once a stereotype has been applied. To allow developers to access profiles without generating them again and again, the idea is to collect them what is called the UML profile store. Technically speaking, the UML profile store is a plugin that exploits extension points. In this way, developers can directly use the profiles in Eclipse tools, such as Papyrus, or access them in terms of a resource, which is helpful for the development of transformations. To sum up, the jump tool precisely defines extensions, uses signatures accordingly, and completely captures features. In the second scenario, which I demonstrate next, the UML profile store is already used. To execute the jump tool on the Padstore reference application, I run the prepared launch configuration. As you can see, several profiles have been applied in this reverse engineering scenario. If user-defined annotation types are declared in the application code, the necessary profile is generated as well. As this is the case for the Padstore reference application, the generated result covers not only a class diagram, but also the respective profile. All other profiles used in this scenario are provided by the UML profile store. Let's navigate to the order class of the Padstore reference application to explore the generated result in more detail. As you can see, the reverse engineered order class in the UML model captures the annotations applied to the application code in terms of stereotypes. Finally, let's execute the slicing transformation on the generated class diagram. The idea is to set the focus only on the persistable elements. To obtain such a slice, the implemented slicing transformation matches on the respective stereotypes of the JPA, such as entity and embeddable. Applied stereotypes facilitate also to improve the quality of the generated slice. For instance, several plain associations in the generated slice are in fact composition relationships. They can be inferred by considering the stereotypes of the member classes. One rule in the last transformation that I execute produces a composition relationship if the member classes are annotated with the entity and embeddable stereotype. To briefly conclude, with jump, we continue a long tradition of investigating mappings between Java and UML, though in our approach we also consider Java annotations in the mapping process.